Hi, let's talk about Brownian motion. On the video playlist, I have included two videos that you should refer to before watching this video. So one is this one, the other one is a actual setup to show you a demonstration of how Brownian motion work. You can imagine the red one is the one that is being visible, and the metal ball are the one that are too small that is invisible to your eye. So go and check that out now before moving on. After you finish that two videos, try to fill in the blanks on your note in this section. Pause the video now.
A few moments later.
Okay, let's check the answer together. Fluid particles randomly move in all directions. Notice that the videos that I showed you earlier, they are just a demonstration. So they are kind of limited by the 2D motion. And so, as you know, our world is 3D, so of course that has to be 3D also. It shouldn't be limited by a plane. The second thing is that each particle will randomly hit or collide on each other, passing through the Ke, kinetic energy or momentum, to other particle. Some visible particles would collide with some invisible particles. So in the videos earlier, there are two pair of example. One is the one being visible is the pollen, and the invisible one is the water. Okay, the water molecule. So that was the original, very early Brownian motion observation. The other one that we could definitely talk about could be the one that is dust particle and the air, and of course air particle would not be able to see directly. Since we are also using kinetic theory, that means particle theory, to explain, you should also recall that when temperature increase, it will increase the kinetic energy. It will move faster, it will vibrate faster, and therefore the movement will be even more vigorous. As for the word describing the movement, like if you can look at the picture that I include here, this is kind of like changing quickly, right? Like the better word to say is abruptly, right? That means it go and then suddenly change very quickly and change quickly, and there isn't really a clear pattern. And another word that can describe this is starting from Z, called zigzag path. Okay, so this is a word that you can use in the exam. The next page on your note will be a sample of past paper questions. So try to pause the video and do it yourself. Alright, first of all, I'm not sure if you can visualize the question. This is something that I'm sure all of you have seen it at home, and that is simply the sunlight shines through the window to your house, and probably you see some dust simply flying around. So that is the situation we are talking about. Part A asks you to draw the diagram to show the motion. So basically, it's the one that we have earlier. So it should be a straight line until a certain point. It go abrupt change, and then another change, like that. All right, I would like to put down some arrow to indicate it more clearly. Part B asking you how come after 1 hour the dust particle is still being visible. So you have to explain basically what we have mentioned earlier. So you want to draw the dust particle bigger probably, and then some air particles surrounding it. So label them as air, and then you may want to say that the air particle will collide with the dust particle in all directions, transferring momentum or kinetic energy, but I like momentum more. Transfer momentum because it also show direction as well. So transferring momentum to the dust particle from below and from above, right? So that's why it doesn't go kind of not going up or not going down. after 1 hour. Of course, I mean, if you're talking about, oh, after a really, really long time, like 24 hours, because of gravity, or probably the dust will be eventually, because it's also like being affected by gravity, right? So eventually you go probably lower and lower, but then it doesn't go directly down to the ground. So that's why after 1 hour it's still there. Part C asking when temperature is only 5 degrees Celsius. So earlier you got to double check, it was 15 degrees Celsius. So now it's colder. And according to, again, the kinetic theory that we have talked about, the kinetic energy will be less. And so what you can talk about in 5 degrees Celsius is you can just simply say, because it's only one mark you can see, you can just simply say less movement. Or you can also say slower. I actually prefer this more, slower movement. You can also say less random motion, because it's not as chaotic. I mean, imagine like the worst case, like it's really having a lot of energy that moving so quickly, then it will be even more random. So these are the possible answers.